Hello all, welcome to the show. I'm Gus Gagliardi and this is Fire Code Tech. On Fire Code Tech, we interview fire protection professionals from all different careers and backgrounds in order to provide insight and a resource for those in the field. My goal is to help you become a more informed fire protection professional. Fire Code Tech has interviews with engineers and researchers, fire marshals, and insurance professionals, and highlights topics like codes and standards, engineering systems, professional development, and trending topics in the industry. So if you're someone who wants to know more about fire protection or the fascinating stories of those who are in the field, you're in the right place. Welcome to episode 15 of Fire Code Tech. On this episode, we have Mike Snyder. Mike is a chemical engineer with a host of professional certifications like his professional engineering license, and he is a certified safety practitioner as well as a certified fire protection specialist. In today's episode of Fire Code Tech, we talk about Group H occupancies and hazardous materials. Mike is the real deal when it comes to chemical safety and hazardous materials. With an over 30-year career in process safety and chemical engineering, Mike really knows his stuff. I had the good fortune of finding a presentation by Mike on Group H occupancies when I was working on a job that was dealing with, as Mike would say, appreciable amounts of hazardous materials in excess of the maximum allowable quantities defined in the International Building Code, and I was just ecstatic to find such a good resource. If you're a little unsure on what hazardous materials are or what are some of the implications in the built environment for hazardous materials, you're going to love this episode. If you want to reach out and have a conversation about fire protection, or if you have an idea for a podcast guest or a topic, you can reach me at ggagliardi@firecodetech.com. Don't forget to follow us on social media and subscribe so you never miss an episode. Let's get into the show. Hello, Mike. Thanks for coming on the show. Hey, I appreciate it.
Well, thank you very much for having me, and I look forward to a robust conversation about my background and also hazardous materials and their impact in the fire protection community.
Definitely. Wonderful. Yeah, I wanted to just get started with, broadly on your career and a little bit about your history and how you have found yourself in life safety and engineering, if you wouldn't mind, Mike.
Oh, absolutely. So, as I explain my career to people, I always have to start with three formative experiences I've had very early in my life. And that was I had a grandfather who was essentially a safety engineer in a zinc manufacturing facility in Pennsylvania. And through him, at a very early age, like 9 or 10, I could see the impact on him and to his colleagues when an accident happened and the joy that would be received when hazards were identified and people were protected. So that was kind of a sentinel experience in my upbringing. And then advanced to age 16, and I had the honor of joining a volunteer fire company, the Aquashikla Volunteer Fire Company, where I was able to see in emergency situations when pre-planning and good design took play, how effective and safe emergency response could be. And unfortunately, you would see outcomes that were bad when emergency response was not considered in building or facility design. And then in my senior year in high school, I had an instructor who developed a passion for me in chemistry. And so those three things together drove me into the field of chemical engineering. And really, that was what started my interest in this area of trying to blend engineering, code issues, and chemistry. And probably one other important event in the beginning of my career was I interned in between my junior and senior year of college for the Dow Chemical Company and spent that summer doing fire protection and loss control engineering projects. And at the end of that session, a couple of senior members of the engineering team took me aside and said, Mike, we really appreciate the passion you bring to this loss control and fire protection engineering. But if you're ever going to be effective in this field, you need to walk a season in the shoes of the manufacturing engineers that you're going to be guiding in the future so that, the first piece of assignment professionally would be to get in the trenches, slug it out and understand the challenges that people are facing there. And so, at that time, that day, that was a very demotivational comment. but yet in retrospect, it was probably one of the most sage pieces of advice I got, and I followed it. And so I did spend the first part of my career in chemical manufacturing, and to see the challenges that face people, not that they don't care about loss control, but it has to be blended and prioritized with a lot of other things that are involved. And from that first assignment for about nearly 5 years in manufacturing, I then progressed through the chemical industry in a number of occupational and process safety roles, and ended my career in the industry the last 8 years working as the global director for both occupational and process safety for Dow Corning Corporation. The other piece during that experience, I volunteered in the municipal volunteer fire service and ultimately became the chief fire officer and fire marshal for a fairly busy and active company here in Michigan, responding about 500 times a year and also getting involved in code compliance reviews. And then I retired in 2016, and since then have joined DACRA. And DACRA Process Safety is a chemical process safety consulting group that looks at all of these different aspects of chemical evaluation, chemical classification, and then the controls in industry and in use and in transportation that get deployed when you're handling these materials. And so there's been kind of that continuum of chemistry through my life, but looking at it in different applications.
That's extremely fascinating. So glad to hear your description of your career. Yeah, I found you through a beautiful presentation on hazardous materials, but it paints an even more vivid picture to hear you fill in the arc of your career so far. So that's really fascinating.
Oh, well, thank you. And, I guess that maybe the other part is, and we'll talk about this, I think, a bit further. Obviously, the first time anyone is exposed to chemistry in kind of a training or an academic setting, right? It can be daunting. And the standpoint here, stay the course. You can learn the principles that are necessary to be successful. You can think about it and distill it down to easy components, and it will make a difference in your professional career. So, sometimes people go, "Oh my God, it's chemistry." It's okay. You will get through it, and you will learn important things for your career.
Yeah, I think that's a great point, Mike. The degree program that I came out of at Oklahoma State University has recently put more emphasis on chemistry and added some more chemistry classes to the degree plan. And I think that's a sound thing to do because, as we keep advancing in material science and keep having different and new hazards, it's a component of life safety that's not going anywhere, and you have to have that understanding of properties and their chemical properties, materials and their chemical and physical properties. So that's great.
Excellent.
Anyways, well, I wanted to move on. I see you have several professional certifications, and I just wanted to get a little bit more about your professional certifications and maybe how you acquired them. I haven't had a certified safety professional on the show yet, so I'd be especially interested to hear more about that certification in particular. If
Oh, sure. So, maybe in the broadest context, professional certifications and credentials are really important in your core areas of focus to have really an independent, let's call it good housekeeping seal of approval in the technology area that you have. I had a plant manager many years ago that I worked for who really encouraged me in this space. And it started the conversation with something like, "Mike, we know you are an expert in certain areas of occupational and process safety, and we respect that. However, as you have to represent our company outside to our neighbors, to the regulators, they don't have that background. They don't have the relationship with you. And these credentials, at least in a starting conversation, say, hey, there's been a third party body that's looked at your credentials, and you have taken a test or two to validate your knowledge." And I think you have to kind of keep that in the back of your mind, that it is oftentimes a competency door opener, particularly as you're dealing with public bodies. And that was kind of how this came to be. My first credential was professional engineer, and that was really to be licensed in the state of Michigan in the area of fire protection and chemical engineering. Subsequently, I worked on the Certified Fire Protection Specialist through the NFPA, and that really is that you have a broad-based set of knowledge in the application of NFPA codes and standards. And then I finished with Certified Safety Professional, which looks at a wide variety of issues from industrial hygiene applications to ergonomics to just some basic scientific calculations in the workplace to reduce employee exposure. The CSP one I did late in my career, and that was when I was the global director of both occupational and process safety in Dow Corning, because I truly believe that as part of a career development plan, you need to find one or two of the gold standard certifications to work through. And that's, there's no place in your career where you can't say, geez, I'm too old or I don't have enough experience and background. You can build that and you can do that. And I wanted to role model that for the people in our organization that, okay, even a old guy late in his career could do that. And I had to work at it, right? It was not a simple piece. I had to do a fair amount of studying and preparation for it, but ultimately was successful. The other thing I'll just briefly go back to is early in my career, we had a lot of people in our organization that were called loss prevention officers, which were basically fire protection technicians. And early in that process, we used a credentialing program through NFPA called Certified Fire Inspector. And it was really a fascinating experience because here you had people with a variety of backgrounds, oftentimes without any type of advanced degrees to begin with. And we studied and we worked and we did projects and they went through the certification process. And first of all, it was a great raise the bar exercise where people really built their capability. Secondly, they were very proud of the credential, and a number of them took that as kind of the catalyst to work on other credentials and in several cases degrees that have really helped them achieve professional success. And so, credentialing not to hold the certificate on your wall, but really as a vehicle to grow your capability and hopefully advance further in this technology area. That's really what it's all about.
That's a wonderful sentiment. Yeah, I appreciate that insight. As somebody who is looking, into working on getting my professional engineering certification in the application process, and I'd looked into CSP and see the value of that and the broad safety that it covers, and the like you said previously, the implications of obtaining these certifications and what that says about you as a professional, and to your employer about your passion for your job. So I think those are all great points.
Oh, no, great. And again, I think both personally and professionally, it's not again, it's not the certificate or the letters, but it's the fact that you've gotten that third party review that builds that professional credibility, right? And that's at the end of the day, particularly in matters of life and property safety, that credibility is extremely important.
Definitely, definitely. That's awesome. So I wanted to get into a little bit of the meat of your specialty and just some topics that I've had some definite interest in lately through project work and through just being in a career in which I'm presented with different chemical hazards on a daily basis. But yeah, I just wanted to speak with you more about your experience with hazardous materials and get into that subject a little bit more with you, and how you got, yeah, just, I know you have the chemical engineering and the safety piece, and you've worked for a chemical company, but the hazardous materials specifically, yeah, I'd like to hear more about your experience with that.
Sure. So, obviously, and I'll start with, I'll call it the academic side, and then we'll step back and I think talk about how you can frame this that it's applicable really to anybody who is going to be touching hazardous materials in our work process. So, most programs in chemical engineering and chemistry are looking at the normal routes of basically how you take chemistry or chemicals and move them from kind of condition one to condition two. Very seldom, and even today in the academic environment, is there a lot of discussion about unanticipated consequences, contamination, or undesired reactions. And that probably is, from a personal mission standpoint, getting that more robustly into our academic curriculum is still something that we need to do a greater deal of work on, right? And if you think about our practice in fire safety, loss control, and process safety, most of what we're really trying to do is, can you identify the potential unanticipated outcomes, and do you have proper levels of protection to deal with that? So, oftentimes, as we talked about, right, chemistry can be daunting. And so the things that, as I reflected upon this in preparation for our discussion here, that I have found to be very effective in dealing with clients and dealing with regulators and dealing with community members is, we have to take complex topics and frame them very straightforward and as simple as we can. And that doesn't mean gloss over important facts, but you need to be able to distill down, what is the exposure, what is the risk, and how are we going to control that? And I always kind of joked, right, if I could explain it to my mother and she could understand it, then I probably got it to the point that it was appropriate, that I've distilled it down to its most simple element. Because oftentimes we love to talk in acronyms, we love to talk in technical detail, and there's a forum for that, right, with colleagues and when people are doing technical review. But many times when you're dealing with a client, or you're dealing with an owner or an authority having jurisdiction, without, again, trying to say, well, you can't understand this, but simplify the problem, and all of a sudden people get on your same page. And then I think you also have to think about the work process. And that is, you're doing some type of work here with this hazardous chemical or with the code compliance there. How does it fit into the broader picture? And the way that I do that is, and as simple as this sounds, it is the root of many problems in chemistry. It starts with, what is the problem we're trying to solve? And again, it's a very simple question, but I ask it 3 or 4 times a week when we get into places where, oh, the client doesn't understand it, or the authority having jurisdiction is being unrealistic in this. I really come back and I ask that sentinel question. And when we have a dialogue there, it's like, oh, we're missing the point, or we're missing the understanding or the resistance of what we're doing. And then, obviously, as you look at that, you need to make sure that you do have that background data that's going to be necessary to support the simplification and the discussion that you have there. Again, if you can kind of frame the issue or the hazard simply, you can think about it in the workflow, and how it fits into the work process. And again, start with, what is the problem we're trying to solve? You will be much more successful, and I would say much more satisfied, when you're dealing with these hazardous chemical challenges in your work.
Definitely. I think it's so easy to get, like you mentioned, lost in jargon. And, it's we get so used to being technical, subject matter, experts on fire protection or life safety, and writing in a language that makes sense to you and properly defines the hazard. But I love that point about know your audience and distill it down, make it simple. Don't it's much harder to distill it down to the absolutely necessary facts than to write a novel about hazard analysis. It's easier to do, honestly, to be exhaustive and use language that's jargon or just overly technical. So yeah, I love that point.
Right. And just, as maybe a quick example of this, I do a lot of work today with clients on combustible dust. And the way that I get people calibrated about this is, any material that's not made out of rock, that has a particle size less than 500 microns, will burn. I can predict that to about 99% accuracy. And the purist would kind of say, well, there's a couple of things on the periphery that, don't quite fit into that. But things that are not fully oxidized will burn. And if the particle's small enough, you have a combustible dust hazard. And it's amazing how you take something that can be very complicated, and if you can get people to say, oh, well, we have a lot of that kind of stuff, all of a sudden you get somebody who's maybe resistive to the fact of, oh, that combustible dust doesn't apply here, to something that says, oh, we may have a hazard. Let's have an additional conversation. Those are the kind of things you just need to kind of think about building in your toolbox to be able to broker those conversations.
I like that. Yeah, it seems like when I speak with a professional who has had success, they will oftentimes peel off a piece of this great tactics or toolbox way to say to bring the technical codes and standards down to a level that's understandable for somebody who is, in business development, or they are, an owner. Oftentimes these people aren't technically savvy, and it's not their job to be on fire protection and life safety. So you have to bridge the gap. So that's a great point. But anyways, I wanted to just speak a little bit more about, what are hazardous materials. It's just, I found it even difficult in my entry into learning how to address these hazards. Is how do we know, what is a toxic material, and or what is a caustic material, or what is a flammable liquid, and how do we know about what those are and the criteria for those? But yeah, I'd love to hear your thoughts on that.
So that is right the quintessential challenge, as you're starting to look at either an existing facility or a new design. And so, there are two model programs or methods that are available to us to classify hazardous materials or any chemical to see if it fits into the hazardous material definition. And there is the United Nations Department of Transportation, UNDOT, which will take materials into one of 9 hazard classes. And those are the ones that are used predominantly for transportation. I'll say this again, but part of this is oftentimes you'll have a material that will meet the qualifications for more than one of those classifications. And you have to make sure that you're thinking about the hazards that are in both. So, for example, you could have a material that's both a poison and a flammable gas or a gas. And you have to kind of, it's not just one or the other. In transportation rules, you have to just be very careful because when you placard a load, some of these are what I would call primary and others are secondary. And there's all kinds of unique rules. You need to just make sure that you open up the safety data sheet or the UNDOT book classification book and make sure that you understand which of those are there. But let me advance to where I think most of us touch this, and that is in the building and the fire code. And the building and the fire code is a bit more granular in how this is done. And it basically looks at any chemical and identifies whether it has a physical hazard that is of interest to the building and fire code or health hazard. There are 17 different physical hazards that are evaluated and 3 different health hazards. And there are a variety of definitions that are used to classify materials, and again, into one or more. And I again will emphasize the or more buckets that have to be considered. And so in many cases, and I'll take the simplest example, right? You could have a material that is a flammable liquid. And the classification of flammable liquid, as we all know, is based on flash point and boiling point. And, you can either run a test in a laboratory or get the supplier through the safety data sheet to look at that. And, you get a lot of people to focus on that. You can come to quick consensus. This is a flammable liquid, it's a combustible liquid, or it is not an ignitable liquid at all. When you go down the list to physical hazards and you start to look at things like pyrophoric, organic peroxide, these are a little more complicated, and the data is not always available. And what I always just tell people is, don't go this alone. As far as trying to make this determination, go back to the material supplier. If it's not on the safety data sheet, call the information line or send an email and probe a bit to see if that data has been determined. And if it has, ask to get a copy of that to try to make a determination. And if that isn't available, partner with somebody. And again, this is not a super expensive proposition, but partner with an advisor in the chemical testing or process safety area to help walk you through the most economic way to make that determination, because this is the gateway determination about whether or not other aspects of the building code or restrictions in the building code apply. And we'll walk through in just a moment. I spend a lot of time on the speaking circuit talking about group H occupancies for high hazard. To make that determination, you need to understand the nature of the hazardous material. And the code allows certain small amounts of material, depending on what code you're using. That could be called an exempt amount or a maximum allowable quantity, or MAQ. And you need to look at every one of the chemicals that are being used and understand what is that threshold. And if you can stay below the threshold, you can normally put that into most typical buildings. There are some restrictions with educational and residential, but for normal commercial buildings. But if you anticipate or have usages above those de minimis amounts, your building has to have special features because it becomes a group H occupancy. And the whole reason for that is to ensure safety of the workers, to ensure safety of the neighbors to this facility, and we oftentimes forget to ensure the safety of the emergency responders, right? The last thing you want to have happen is a small fire or other event happening in a building with hazardous materials, and because of some building deficiency, emergency responders are injured or killed because the building's not able to withstand that challenge. So it starts with understanding in the model codes, right, which again would be NFPA 400 if you're using the NFPA series, or Annex E of the International Fire Code, to really try to understand the definitions of these 17 physical hazards and 3 health hazards. And if you have more than the amount of material that's allowed, for example, in the International Fire Code in Chapter 50, that your building has to have these additional features.
That's a great point about how to find those definitions. I think this is such a good topic to go over because if you are not um, effective in classifying your materials to begin with, this is the first step in the hazardous analysis, or determining the impact to your facility, whether it be existing or new construction. So, yeah, I think if you are unsure about these factors, then you need to stop. And I like what you said about reaching out to the manufacturer and establishing the data through those channels, or usually there's material safety data sheets. So those are also a good resource for these different hazard category properties. Yeah, I like what you said about flammable and combustible liquids, and how flashpoint and boiling point are the metrics in which we decide whether things are flammable and combustible. And as you start looking at these topics, those are some of the more straightforward in determining, and oftentimes have some of the easiest data to retrieve so that you can classify these things. But yeah, no, I really like that description.
And again, as we start to talk as fire protection and process safety professionals about this issue, it is extremely important that we help lead that conversation, because many people who are occupying these facilities, running these facilities, or designing these facilities, even say a typical architect, oftentimes don't have all the depth of knowledge. And we need to kind of make sure in a simple way that they understand what's there, because there's two really important, I'll call them milestones, right? When you're designing a building, right, the design features of that building, it's easier to change on paper than once the building is built. And so you have to have a very frank conversation with that design team and the owner about, do you want this building to be able to handle in its lifespan materials greater than the exempt amount? Because if you do, you probably want to invest now in the additional features. And they have expense. They have capital implications. And so there's always kind of this resistance. Because once you cast that die and you say, okay, I'm not going to invest in the group H features, they are very complicated and very expensive to add. And so during the life of the building, you also have to be careful that you manage change correctly. So if all of a sudden a new formulation comes in or a new product line, somebody has to go through this exercise again to say, all right, our building has limits. Let's look at the chemicals and the amount of chemicals that are going to be there, and are we exceeding the amounts? Because oftentimes, in today's world, I get involved with clients who have missed that milestone. Right? They have an ordinary F1 type of occupancy, a normal manufacturing building. They've changed formulations, and all of a sudden, they are 2 or 3 or more times what's allowable by the code before you're in Group H occupancies. And obviously, there are a variety of reasons that are situations where that's discovered, and then you're under extreme duress, right? Because you may already have launched this product, and now you have a building that doesn't conform to the requirements. So, management of change, we may talk a little bit about that later in our discussion today, but that is an area where, this is not just a chemical industry thing. This management of change hits all aspects of industry, and we need to make sure we're sensitive to that.
That's a great point. I like that. Yeah, I've spoken previously with a loss prevention specialist, and he was bringing up this term. I probably haven't heard it since college, but management of change for a building owner is a definitely important aspect of a building owner's approach to life safety, and just making sure, we see management of change in many industrial processes, but oftentimes it's overlooked as it regards to fire protection and life safety. So I think that's a great point. But no, I just wanted to proceed in the discussion with a little bit more information on, we talked a little bit about H occupancies, but for maybe those who aren't as familiar with what we're talking about, yeah, would you speak about occupancy classification and what that means as it relates to the building code and the model codes in the U.S. As a baseline understanding for our discussion leading on about H occupancies?
Sure. So in the model codes, there every structure or part of a structure is designated normally with a number or a letter and a number classification. So you'll have something like F1, H2, S1, and that letter and number designation start to indicate the nature of the operation, or the nature of the activities that go on in the building. And while some people will smile and laugh a little bit about this, it is the building code tries to match the limitations and restrictions of a building with the nature of the hazards that are going on. Some people would say we're not quite there yet. Uh, we're getting better, but it really is trying to make the loss control and life safety features commensurate with the risk or hazard that exists. And so, in most situations where we have manufacturing operations and chemicals, the typical occupancies that we will be dealing with are F1, S1 or S2 for storage, and there's some limited operations that can go in there, or the series of H classifications, and presently that's H1 through H5, which represent high hazard occupancies. When you cross the threshold from what I would call more low hazard occupancies, F1, S1, S2, to one of the group H occupancies, the building code then has limitations on building height, building size, and other requirements, including emergency power, ventilation, and in some cases, what they call explosion control. But think about it as explosion venting of the building. So when you are looking at this, you need to kind of say, look, if I have the hazard, which is normally looking at these material classifications and overlaying that with, do I have more than the allowable amount? You have to really then say, okay, I am then prepared to invest in those protections. And again, it's not today only. It's looking at the lifespan of this building, because, for example, if if your building is limited in size, and now you build a larger building and cross that Group H occupancy, it becomes very difficult. You may end up having to put additional firewalls into a building retroactively, or explosion venting, and those are just very difficult situations. So, again, I would say in today's arena, we don't spend enough time, and it's not that it's a detailed or very difficult study, but read the definitions in the building and the fire code. Spend an hour, of what, Group A, Group B, Group F, Group H, and they're very well defined. And it, photocopy the papers, or kind of write yourself a crib sheet, because that's just something that can kind of help guide where you're going to be. Number of papers that I've written for the Global Congress of Process Safety on this, in trying to just educate the broader community, from architects to chemical process safety engineers, because it's just something we don't spend a lot of time doing. But crossing that, I would say today, one of the biggest challenges we have in the built community is people who cross over that Group H occupancy threshold and don't recognize it. We are creating unintended risk for the communities I talked about, the employees, the neighbors, and the emergency responders. And obviously, that's not people's intention. It's just an oversight that creates that exposure.
Definitely. Yeah, I find that people are not aware of high hazard storage, or high hazard commodities oftentimes. So, sometimes these thresholds can be not exorbitant amounts of these materials. So you might cross one of these thresholds without even realizing it if you have something that's particularly hazardous. So yeah, I think that's a great point. You can cross these thresholds fairly easy if you're dealing with a nasty material.
Ri- Right. So, materials that are highly toxic, uniquely reactive, like pyrophoric or unstable, the thresholds are on the order of a few pounds, right? Where with like flammable liquids, those thresholds start at about 120 gallons. And then there are some additional allowances in the code. For example, if you're sprinkled, you adequately sprinklered, you end up being able to get some adders in there. But again, even with flammable liquids, you're dealing with a couple of 100 gallons. So again, if you're using just a few gallons, probably not a big issue, but it is very easy to get above 200 gallons, right? That's 4 drums. That's not a lot, or it could be one IBC of liquid that get you over that threshold. So it's easy to happen if you're not deliberate and disciplined in your approach.
Definitely, I agree. Yeah, so that's great. Yeah, I definitely agree. You need to be aware of these chemicals and the thresholds, and so yeah, that's a wonderful point. I would think I wanted to proceed with, we talked a little bit about the impacts of the age occupancy, but I just wanted to circle back. I think we talked about it. Yeah, if you touch on the critical factor that pushes an occupancy over into H occupancies, and then yeah, maybe more explicitly, what I know you said, like deflagration venting or explosion venting, and explosion proofing, and some of the other
Yep. Yep.
stuff.
Okay, so again, the at a very high level, the strategy that you do is you build an inventory of the chemicals that you're planning to use. You're going to figure out, so right, you could do this on a spreadsheet, as an example, which of the 17 physical hazard categories and or 3 health hazard categories apply. And for each one of the boxes that you tick, right, and again, for a chemical, there could be multiple designations. You would go to the applicable tables, either in the NFPA Fire and Building Code, or into the International Fire Code, to see what the exempt quantities are. And if you are going to be above those quantities for any of those line items, that module or part of the building has to be classified accurately as a Group H. And again, then the numbers talk. H1 is an explosives, right? High energy type of release, all the way through down to H3 and 4, which are lower pressure, flammable, and combustible liquid scenarios. And H4 is health hazards. And so those then drive a number of requirements about the building. So, specific to your question on explosion venting, when you are dealing with high volatile and high energy release materials, that could result in a deflagration. So that would be a high energy flash fire. You want to make sure that the pressure that's built up in the building or that room is able to be relieved to a safe location. And so, for example, if you have very volatile, flammable liquids, so like class 1A or 1B handled above their boiling point, you can easily in a release fill a room completely full of flammable vapor, right, that could ignite. And when it does, it's going to release a lot of energy. And so you need to make sure that the walls of the building are able to withstand that pressure, which oftentimes means we put some explosion venting there, right? Because the whole goal is for a life safety application, buildings that collapse obviously are going to present a huge life safety risk to the occupants. And so you're trying to reduce the pressure, the lateral pressure on the walls, by doing explosion venting. And the same thing with certain flammable gases. You would end up having to do you would have to do some explosion venting. And there's a section of the International Fire Code, Section 911, which is just interesting because that's our emergency telephone number. But it gives you kind of what hazards require you to deflagration vent or do other types of protections. I'll just will also, and again, not that we go down too deep today, but recognize deflagrations can be vented. Detonations cannot, right? And detonations just mean that the flame speed is faster than the speed of sound. You just aren't able to vent those. You have to do other strategies, which could be distancing or building your building to be able to withstand certain aspects of that. So, as we talk about detonation energy, that's really a whole different type of protective strategy.
That's a good note. I like that. Yeah, been dealing with some facilities with munitions recently, and so getting into some of those detonation hazards. So I appreciate that qualifier. Um, so I know you spoke a little bit earlier about combustible dust, and there's another fairly common but trickier hazard that I've come in contact with in my design career. And I just wanted to hear a little bit about how do you even begin to address this hazard? Owner comes to you and says, "Oh, I want to have metal grinding with the dust collectors." How do you begin to address this hazard as a safety professional?
I think most people have read a lot of articles recently in the trade press about NFPA 652, which is the fundamentals of combustible dust, which really provides the overarching framework for the handling of the hazards of combustible dust. And it is the document that establishes requirements for conducting what are called dust hazard analyses, which I'm going to oversimplify it, but basically it's test your materials or use other ways to determine if you have combustible dust. And if you do, look at the hazards both inside equipment and the fugitives outside equipment to make sure that you have adequate controls. If you don't have adequate controls or add protections to do that. The way we basically say is for both the fugitives and for the equipment, establish one or more bases of safety. If you can't establish a basis of safety to prevent the event from happening, make sure that you have adequate control measures like explosion, venting of equipment, isolation or suppression, or a combination of those. In the example that you used about metal, one of the things that NFPA has done is 652 is kind of the general document. They have additional allowances and requirements in what they call the commodity and industry specific standards. And so while 652, NFPA 652 is I'll call it the overarching document, when you're dealing with metals, NFPA 484 has certain requirements, particularly for high energy reactive metals like aluminum, as an example. NFPA 61 deals with the agricultural community. NFPA 654 is more of chemical industry dusts or areas. And then there is also NFPA 664, which deals with woodworking and wood dust. So those really kind of provide that overarching requirement. I'll just kind of add, and again, there's a lot of things going on with the impending deadline in NFPA 652 of September 7th, 2020, to do your first dust hazard analyses. And that's important, right? That people stay focused on that area. But more importantly, as you look at the International Fire Code, there are two things I always want to remind people about combustible dust. The first is that since 2012, if you handle combustible dust in any configuration or method that can result in a fire or a deflagration hazard, you by default are a Group H occupancy, and that for many people, even though that requirement's been there since 2012, that's a new piece of information. And I would just encourage you to go to Chapter 50 of the International Fire Code to look at that. Since 2018, in Chapter 22 of the International Fire Code, the conduction of a dust hazard analysis, or DHA, is actually required. So, by regulation, it is the first regulation that requires you to do a DHA. So, once your jurisdiction adopts the 2018 edition of the International Fire Code, if there are no other amendments that change this, you end up having to do a DHA within 3 years of the adoption, that are there. So those are requirements that are, I'll call them, that they don't conflict with NFPA 652, but they basically bring more teeth on a regulatory basis to the application of NFPA 652.
Yeah, that's great. I enjoyed your response. I think it illustrates the complex nature of, if you've never dealt with 652 or any of the other NFPAs addressing the combustible dust hazard, it can be quite a lot to find out which NFPAs apply and how you determine if the scope of the NFPA document applies to your particular hazard scenario. So I appreciate that response.
Great.
So I wanted to speak about a little bit about the tragedy that recently happened in Beirut, and I know there's been a huge buzz in the community about ammonium nitrate. I just wanted if you had any thoughts on that, Mike.
Oh, absolutely. So, let's preface this by the fact that there's a lot of details that still have to come forth, and while I think there are some things that are very obvious as we look at this, I am sure some of the details may change the view exactly of the scenario and how it played out. But and I'm going to call it, frustrating part about this is ammonium nitrate has been involved in large loss incidents for more than 100 years. And the basic premise and causal factors that are involved have not changed, right? So basically, ammonium nitrate is classified as an oxidizer, which means when exposed to fire, it will accentuate the fire by essentially giving it more, and I'm using in quotation marks, oxygen, but more oxidant so that you can enhance combustion. So ammonium nitrate normally as a solid, which is oftentimes in prills or flakes as it's stored, is all by itself is fairly stable and you don't worry about it. It is when you expose it to heat or contamination and store it in large quantities, that piles that are put together, and a fire occurs, the results are cataclysmic, right? It's the outcome is literally predictable, right? And a person that I mentor with, a gentleman by the name of Gordon Graham, always says, if it's predictable, it's preventable, right? You can put controls in place. And so all of the things that we need to be working on are, how do you isolate the material so contamination cannot occur? And if there's going to be a fire, ammonium nitrate is generally not going to be the start of the fire. It will be some other combustible commodity. How do we end up putting that fire out, or controlling or preventing the fire from occurring? It appears in Beirut that this warehouse where the ammonium nitrate was also had other commodities, particularly fireworks and probably some other combustible commodities. And so the fire likely started by an area that, something that was not ammonium nitrate. But then once the fire got going, and you look at these historical events that have occurred, usually within 30 minutes to 90 minutes, with the fire that continues to burn, you get a ferocious fire because of the presence of an oxidizer, and you progress to detonation. And these detonations are horrific. In the U.S., our most horrific ammonium nitrate detonation was back in 1947 in Texas City. And that was a boat, a ship that had ammonium nitrate fertilizer that caught fire in the Texas City ship channel. And there, I think like about 580 people were killed, including the entire Texas City Fire Department. So these types of outcomes are predictable. And so, obviously there's a focus on our building and fire code in how we manage those, right? And how we control the hazard, and in making sure from an emergency response standpoint, we address these hazards and know that, generally speaking, if fires get into these stores, it's something that we have to isolate and evacuate quickly. This brings back memories, for example, of levies in liquefied petroleum gas. Right in the 1970s, the fire service went through a large epiphany about fires exposing propane tanks are ones that if you can't immediately get water on, you have to evacuate. Else, there's going to be a levee, and people are going to be killed, and property is going to be damaged. I'll just say one other quick thing here, and we can explore a bit further if you'd like. In the U.S., we recently, and I mean in 2013, in West Texas, at an agricultural supply house, we ended up having a fire, and in about 30 minutes, a detonation that killed, I believe, 15 people. And the U.S. Chemical Safety Board has done a comprehensive investigation that you can go to the Chemical Safety Board website and bring that investigation down and look at it for free. I would encourage you to read that. The frustrating part about that is there were two items in that investigation that were highlighted, and one was what appears to be an oversight in the U.S. process safety management regulation was to not include ammonium nitrate as one of the chemicals covered by the standard. That has not yet been resolved. And then the other one is that OSHA 1910-109, which is titled explosives and blasting agents, right? So people kind of immediately go, well, I'm using ammonium nitrate. I'm not an explosive or a blasting agent, but that has application for the storage of ammonium nitrate. Paragraph I of that standard has requirements. And so, I don't think necessarily that there's going to be a lot of new requirements. The science is pretty battle tested. I think it's our application of this science and our awareness of the hazard that has to change.
Interesting. Interesting. Yeah, I appreciate those extra resources. I will add them in the show notes so people can go and read more if they so choose. But yeah, I appreciate that. It's a little bit baffling to me to think about an oxidizer as something with a detonation hazard. I guess, just from the fundamental idea of, an oxidizer speeds the reaction of combustion, I guess. But I guess it makes sense.
Well, and again, I promise here not to go too far down the rabbit hole, but what really starts to come into play here is it's the contamination. So, for example, once you get a fire, and the Texas City Chemical Safety Board report goes through this in some detail, a lot of fires generate soot. The soot is it's comprised of carbon based materials. Those can also serve as the source of the contamination, right? So if you think about, for example, how people would say blow up stumps in the agricultural community, they take fertilizer grade ammonium nitrate, they add some diesel fuel, and then they basically have something like a small stick of dynamite or something to kick that energy off. It's that contamination, right, intentional in that case, of diesel fuel, that really provides the fuel. You have the oxidizer and you have the ignition source that ends up in the detonation. One of the things in our current hazard communication and classification scheme, so these physical hazards and health hazards, do not deal very neatly with how do materials, when they're contaminated, react. And I would just draw people's attention. The Chem Safety Board is investigating an event right now. They don't have the report complete, but last year in 2019, there was a terrible explosion at the AB Specialty Silicones plant in Waukegan, Illinois. And it appears that a material that nominally would be classified as a combustible liquid got contaminated, and that contamination is what created the instability. And our model codes and standards don't have a real clean way to handle that. So I think that, as we talk about what do we need to do to be successful in the future, looking at how, I'll call it the undesired or unanticipated routes occur, we have to really try to make sure that we have even more accurate ways to make that classification.
Very nice. Very nice. I appreciate that. Yeah, I think the contamination part of it is definitely what I didn't understand or fully grasp. So I appreciate that. Well, I just wanted to put a nice cap on our interview with some professional development topics, since it sounds like you have such a good pulse on what the industry is doing in professional development and career progression. So I just would be kicking myself if I didn't get a chance to ask you about how, as a professional, we should be looking forward or looking for new ways to get a leg up. But, anyways, I just wanted to start with um, kind of what do you see as a trend in the industry right now?
Okay. So we've already talked about one, right? And that's professional credentialing. If I go back to the 1980s when I came out of undergrad, there was not a lot of discussion about professional credentialing. Today, I think in our community, it's becoming more and more relevant and more impactful. And we've explored that. The other area that I see as emerging, and there are a lot of reasons for this, is we are moving from our historic view of what I would call prescriptive requirements and prescriptive codes and standards to more risk based and performance oriented standards, right? So there are drivers where, economics of I don't want to put all the protections in place. I don't want to inspect things as frequently. And if the hazard can be justified that you don't need to do that, right, there's resource and financial benefit for that. But you have to be careful that these risk analyses that you do are not just mathematical exercises to justify an outcome. They have to really be pure and ethical to make sure that the hazard and risks are accurately classified, right? So the opportunity is that I think for many of us, we can become more enriched in the ability to do operational risk management, and really unlock new potential here, right? Which opens up a whole new way of study. This is something our colleagues in Europe have been doing for 30 years, right? And so one of the big debates on a global stage is the European regulatory environment and the US regulatory environment are very different. So in the US, right, we have these prescriptive codes, it's a menu. If you have this, make sure you do this, and you're good. So the good part of that is, right, pretty straightforward what the requirements are. The problem is in many cases the requirements either overstate the requirement of what really needs to be done, and that can cost you time and money. Or sometimes they completely miss the requirement, right? And we kind of go, I just need to check the box. In the European construct, the owner of the hazard has an obligation to prove its safety. And oftentimes there's not a lot of other regulatory requirements. And so you have to really assess all hazard channels and make sure that you have really good controls in place. And so it's a whole different way of liability and regulation. Again, that will not get resolved immediately, but many of the US standards are starting to allow this risk or performance based analyses. And for me, that's exciting. And I think those folks who really embrace that technology and that science are going to be a bit ahead in the field.
That's a really interesting note about performance-based design. Talked to several professionals recently who have more knowledge about the subject, and yeah, I find it fascinating as well. And just the ability to have that as a tool in your engineering toolbox in order to problem solve more effectively and provide solutions for building owners that are a little bit more out of the box, if you will. So I think that's a great point.
Yeah, just and maybe one closing comment on that piece. With the internet today, the ability to search for incident history and incident data, right? I mean, if I go back 30 years ago, right, you have to kind of do library searches, and it was very difficult. So when you do a performance or risk-based design, right, there's an obligation that the basis of what you're choosing has been, I'll call it battle tested with some of the different incidents that are out there. And right, the older the incident, the incident record may not be quite complete, but it is incumbent upon us as professionals to make sure that we're looking at the incident record to make sure that what we're proposing is not outlandish. Right. And that comes into this professional competence and ethics part of this so that you don't just do a mathematical exercise. So, the internet has really enabled that kind of data searching that we never have really had before.
Yeah, that's great. I appreciate that. Um, Mike, I just wanted to end with if there are any resources in which you would recommend to professionals that want to know more about hazardous materials or life safety or process safety or loss prevention. I know that's a tall order, but yeah, I just wanted to get your sense of what resources you find that are quality in the pursuit of knowledge on these subjects.
So, oftentimes I'll go back to what I would call sentinel resources. So, maybe as a couple of quick tips. I mean, some of these are simple, but sometimes people overlook them. NFPA has a large number of standards that deal in this area, and you can view for free and see all the changes that are being proposed by simply going to www.nfpa.org/the standard number. So, for example, the Hazardous Chemical Code, NFPA 400, if you do that, you can bring that information and without having to buy anything, you can look at proposed changes, you can look at the standard and the other areas that are there. For a small fee, you could also buy handbooks that NFPA produces, which are more application tips that take a bit of a deeper dive of how people apply there. And so those are what I would call consensus oriented. So they kind of represent the best view of the consensus community on these, and they are very, very helpful. The other place and again, so that's kind of a US view as maybe a simple and low cost option. To give you a bit of the European view, I find that the United Kingdom Health and Safety Executive, also known as HSE, has a number of resources. First of all, printed in English. Number two, they're free, that you can look at on both the risk analysis and on fundamentals of chemical hazard. They also happen to have a lot of resources on composite IBC fire safety, and you can just search their website. So the UK Health and Safety Executive, think of them as the UK's OSHA. It's just that they have a very comprehensive set of resources that can help owners of the hazard properly control those. So, if you walk away with those two things, I think they give you a great insight. I mentioned before, and I'll close this question simply with saying that the United States Chemical Safety Board for 20 years has been investigating events and publish thorough reports, and in most cases generate kind of a 10 to 20 minute video vignette that overlooks or oversees the event and the recommendations of the investigation. Those are also great repositories of historic knowledge, and I think for especially educating employees who might be working with similar hazards, again, another free resource that can be very impactful.
That's a great point. I love the tip about the European resources. Those are some I'm not as aware of. Yeah, and yeah, I had forgot about the videos from the CSB. I'd watched some of those in college in my occupational safety classes. So yeah, those are. I need to try and find some of those. It'd be great if they had those on YouTube or something like that.
Well, and they do, right? So you can go there. One other, just as we're talking here, I'd be remiss, particularly for those in your audience who are in college right now. The American Institute of Chemical Engineers produces a chemical hazard series called SASH modules, which are really trying to integrate these concepts of chemical process safety into the undergraduate chemistry and chemical engineering area, and undergraduate students get access for free. So again, as you can kind of see here, I try to really be economic in my view of where I point people. But if you just look SACHE, SACHE, um, and search that with American Institute of Chemical Engineers, and you're an undergrad student, you can get access to them for free. If you're not an undergraduate student, they have a small fee attached with them. But that is kind of another area. And I'm sorry, as we're talking here, one other idea that has come here, the American Institute of Chemical Engineers also publish a monthly one-page bulletin called The Beacon. And The Beacon reviews in a very simple way one aspect of chemical process safety each month, and they publish it in nearly 40 different languages. And what I have found very effective about that is you can put it in a control room, on a lunch, on a bulletin board in a lunchroom, in the language that's commonly used wherever you're going to go internationally. And it's one you can go right on to AICHE and subscribe so that you get the email link every month. It's free. And it's quite effective, right? So, for example, management of change is featured frequently in that forum, but other types of scenarios to help build your mental hard drive with scenarios that you should be looking at. So it's kind of a neat, quick way to kind of refresh your memory about how chemistry can act in unanticipated fashions.
That's a great tip. That's a great tip. I appreciate that. I haven't heard of that one either. But Mike, I just wanted to thank you so much for coming on the show, and I want to try to be mindful of your time. And yeah, I just want to say I really enjoyed it, and thanks again, sir.
Great. And again, right, if people want to advance any of these topics, I'm on LinkedIn. Feel free to reach out to me. This is an area of mission of developing our profession with chemistry that I have a lot of personal passion about. So, anybody who has a question or wants to explore these topics in further detail, I'm more than glad to do so.
Great. I can add some links to your work and different articles that they can read from you, as that's how I found you, and I appreciate all the work that you've done. So I'll add some links so people can find you and give you a shout out if they want to learn more.
Excellent. No, and thank you to anybody who's sat through this, because again, chemistry can be viewed as a very dry topic. I just think it has a lot of relevance to exposures that we have and that we can successfully control.
Definitely. I agree 100%. Thanks for listening, everybody. Be sure to share the episode with a friend if you enjoyed it. Don't forget that fire protection and life safety is serious business. The views and opinions expressed on this podcast are by no means a professional consultation or a codes and standards interpretation. Be sure to contact a licensed professional if you are getting involved with fire protection and or life safety. Thanks again, and we'll see you next time.